Hey guys, welcome back. Today we are going to explore how CAMAssist uses AI-driven cutting parameters to calculate feeds and speeds, and how these variables can be modified. Let's open CAMAssist to see how this works. In the Tool Use tab, I have a number of cutting parameter settings. I can choose to only use feeds and speeds from the tool library or the tool DB file. In the case of Mastercam, I can choose to have CAMAssist calculate the feeds and speeds with AI, or I can choose a hybrid of these approaches. We can also see that each of these choices will reflect what is available in the tool use table. Presets, or my user-driven parameters, are shown with a blue border around the allowed use. Cutting parameters are also affected by the material selection. We also have a slider control that can preset AI-driven parameters to be more conservative to the left or more aggressive toward the right. This slider is only shown for the two choices where CloudNC cutting parameters are selected. These are the bottom two radio buttons. We will keep the slider somewhere near the middle. Let's run CAMAssist on this part. We won't run through all of the details here, but check out our other videos for more tips and tricks for running CAMAssist. Okay, we've finished running CAMAssist and have generated the toolpaths in Mastercam now. At this point, we can make edits to the individual toolpaths. Let's have a look. Let's select the first operation, facing. Now, we can edit this as we normally would in Mastercam, by expanding and selecting the parameters option. I'm just going to cancel this because we are going to use the CAMAssist Cutting Parameters Explorer instead. So I will right-click on the Facing toolpath, and then I will choose the very bottom item on the menu, Cutting Parameters Explorer. This tool is installed as part of CAMAssist. The diagram shown in the Cutting Parameters Explorer will vary depending on the tool type and operation selected. For this facing operation, we can use the Cutting Parameters Explorer to adjust the depth and width of cut. What makes this tool different is that it applies AI to dynamically adjust all of the related parameters to create a balanced toolpath operation with consistent tool load. This helps to not only ensure better milling results, but can enhance tool life. The cutting parameters inputs include the operation, if we hadn't already selected the operation in the Mastercam tool operations list. We could use this view to do so. The material carries over from what we picked in CAMAssist, but we could change it here if we wanted to apply a different set of parameters. The machine settings include those from Mastercam, and the variables we set per machine in CAMAssist. Here we see a view of the face mill in the tool settings and the parameters that have been carried over from the selected tool DB file. What makes this tool different is that it applies AI to dynamically adjust all of the related parameters to create a balanced toolpath operation with consistent tool load. This helps to not only ensure better milling results, but can enhance tool life. Finally, we have the Application tab, where the work holding and usage variables can be readjusted. Each of these changes will only affect the selected operation. Recall the slider we set on the Tool Use tab of CAMAssist? Here it is again in the Cutting Parameters Explorer. Here we can apply a coarse adjustment to the parameters for each toolpath. Notice each time a change is made, the whole model dynamically updates. We can see the change in the diagram and in each fine-tuning element. Once we are happy with the changes made, we can select the Save Operation button. This won't automatically update the operation in Mastercam, though. At this time, the Cutting Parameters Explorer changes do not make a toolpath dirty in Mastercam. We will have to regenerate the operation in Mastercam for the changes to take effect. If there are any cascading effects, we will also have to correct those by regenerating the toolpaths. Let's have a look at another operation type. The first roughing operation will allow us to see the cutting parameters of an end mill. Much like the previous example, there are a number of variables involved. Some parameters can be locked, so they are not affected by changes. Otherwise, each change will be dynamic for all variables. Parameters can also be unlocked and reloaded to their starting values. If we look at chip load, we can adjust the maximum value so that the value used is reduced. Along with the diagram representation, the Cutting Parameters Explorer also features a heat map view. These views can be useful in pointing out issues or peak performance levels for certain tools and operations. As with the diagram view, the heat maps update as the parameters are adjusted.
Before saving changes, the values can be checked by clicking the Configuration button. This view allows you to see all of the parameters and edit them further if you wish. Changes here are not dynamic, so be cautious. Once you are satisfied, save changes. Each operation and tool type will have different cutting parameters available. It is also worth thinking about the Cutting Parameter Explorer as a view into the CAMAssist artificial intelligence engine for feeds and speeds. As you can see, it is a comprehensive model that takes numerous variables into account. Whether you want to make your roughing toolpaths more productive or your freeform operations produce smoother machining results, the Cutting Parameters Explorer can help. Give the tool a try and let us know how it is working for you. CloudNC is continuously working to improve this tool and make your machining tasks easier. Thanks for watching, and we'll see you in the next video.